Okay, guys, let's solve this equation that says x squared minus 5 times the absolute value of x plus 6 equals 0. This can be done in a couple different ways, but one way we can recognize is that the absolute value of x squared is the same as just x squared itself. You know this because if you graph x squared, it looks like this. If you graph the absolute value of x squared, it looks exactly the same. The graph of this and this, they both look just exactly identical. That means this can be replaced with this in our equation. Otherwise, maybe you couldn't do that. Okay. So we'll say the absolute value of x quantity squared minus 5 times the absolute value of x plus 6 equals 0. So notice the key step I'm applying here, which is what? I'm replacing, right, in this position, x squared with the absolute value of x squared. Okay. Why would I do that? Because then I can factor, for example. Okay, so some people will see especially something like this and then like this here, and they'll get really thrown by the factoring process because you've got absolute value bars and not just single letters. That's okay. So then you can always try this. You can say u equals the absolute value of x. This is called a variable substitution, and it's helpful for sometimes recognizing forms more easily. It doesn't have to be used, absolutely not, but it's helpful sometimes for some people. Okay, so I will now be writing my equation as just u squared. So what am I doing? Look very careful. I'm replacing this thing with this. U squared minus 5, and again, I'm going to replace this with just the letter u, because u stands for absolute value of x. Plus 6 equals 0. Some people will find this form easier to factor. It looks more familiar. So I need two numbers that now will multiply to 6. I get to multiply to this, and I have to add up to negative 5. So I will do u minus 3 and then u minus 2. This is equal to 0. You can check. Negative 3 times negative 2 is 6. Negative 3 plus negative 2 is negative 5. So we get checks on the middle coefficient and a constant. From here, you got to set each factor to 0. So u minus 3 is 0. Other possibility is u minus 2 equals 0. Solve for each u. So u is 3. I'm adding 3 here. Or u is positive 2. I'm adding positive 2 to both sides. We can't stop there. Why not? Think back here to this step. Right? We set u to represent the absolute value of x. I'm talking about this part now, here. Correct? You got to replace u with the absolute value of x back. Okay, so that means down here I will say the following. For this part, I'm going to put now back absolute value of x equals 3. For this part here, I'm not going to put back absolute value of x equals positive 2. So this is now one of the simplest possible absolute value equations. This is true when x is 3 or negative 3. This is true when x is 2 or negative 2. So as you can see, altogether here we end up with 2 solutions from here and an additional 2 solutions from here. So we have 4 solutions. If you don't believe any of this, then you can always do something like, okay, you go and you graph it. When you graph this, it looks like this. I've graphed it, and it goes through these values of x right here. This is the graph. It's at negative 2, it's at negative 3, it's at positive 2, and it's at positive 3. All right, and remember that those are the roots, because here, what do we have on the right side? 0, correct? When you have a 0 here, that's like saying y is equal to 0. When you say y equals 0, you're saying the graph is going to the horizontal axis. Okay. Leave a like if it's helpful.